Welcome to the part 2. So in the part 2, we will actually start the development of our first milestone. That would be like the context history, where we'll be managing or saving the history and then, setting it up. And just a heads up, I don't have any plans at the moment in a sense that I haven't made up my mind like, okay, this is how I'm going to do it. I'm just spontaneously attempting to do it. Okay, so this is the plan that I have, what we discussed in the last call, only the mental model, like what exactly this is and how it should be. And today will be, the first thing will be attempting this part, the context and LLM API. And from the previous video, we already know that we're using DeepSeek, right? So here's the thing. Yesterday, uh, I made some boilerplate code. Let me show this to you. Yes. So I have the DeepSeek API key in my DeepSeek API key in my ANV, and I'm using that. And then this is a boilerplate code that I got from the documentation itself. So we just call their API and then just send this payload. Model is DeepSeek V4 Pro. I think I'm gonna make it Flash to save some tokens and the cost. And then we're sending that you are a helpful assistant. Your name is Cairo. You will always respond with a metaphor in the beginning, followed by the actual response. And then we send the prompt, and thinking is enabled so that it will. If it's a reasoning model, it will think. If it's just an LM, it won't think. Okay. And reasoning effort is high, and then the streaming is false because we don't want to stream. We just want to get the result. That's what we're doing right now. Very simple. Okay, and then we're adding some authentic headers, and then we're using Sky. It's similar to fetch, but with fetch, you have to add some more boilerplate code, like checking if it's okay, and then encoding it to JSON. I mean, sorry, decoding the JSON, all those stuff. So this will take care of everything in one line. Okay, so it's just like very convenient way of doing it. You can also do it with fetch Axios or whatever you want. Okay, so very simple code. And an index.ts file, all I'm doing is I'm running a main function that will call the LLM API key, sorry, LLM API caller, and then it will just send the prompt. And then I'm also not taking care of any type safety here at the moment because that's not my concern at the moment. My concern is just to get an idea like how things work. And just FYI, this won't be any library or something that I'll be releasing. This is just a very bare bone project I'm doing for myself to learn and also sharing with you guys as well. Okay, how I think when I'm doing it or what are the problems I run into. So it makes sense. Like if you guys are also doing it, it also makes sense for you guys also. Okay, so that's what the entire thing is. And then we're iterating over the choices because the response you get is actually an array of details. So including both the agent's response and your user response. So we just console log it. So let's just run this. And in my env, I have the DeepSeek API key. I'm not going to show that, but you have that API key there. So I'm going to trigger this. I'm going to run bun, run index. And by the way, I'm using bun. So everything is here bootstrapped with bun. Okay, so you can see here, I ran, hey, who are you? And then it says like a compass that always points north. I'm here to guide you. My name is Cairo. Just take a step back and think about this. So in the system prompt, I explicitly specify that your name is Cairo. Right, so let me remove this. Okay, save it, run it again. So now it says, I'm a curious librarian who never sleeps, always ready to open a new book to answers for you. I'm an AI assistant created by DeepSeek. You can see how the entire narrative shifted here. So just with a few lines that I removed, it now doesn't remember who it is. It just uh, proceeds to the default configuration. And let me tell you one more thing. this whole sentence here, okay, that you see, I am an AI assistant created by DeepSeek. This is not something the DeepSeek team has embedded into the LLM training data. This happens in the supervised, I think it's called supervised learning phase, post training. So after the base model training that they do with all the internet data, so they explicitly feed this example data. Like if, for example, if I ask, hey, what is your name? So there's a human tester or let's say an automated script also that will actually do this. It will teach the model like if someone asks you like, who are you? You're gonna say this exact thing. You're gonna say you're created by DeepSeek. So they keep feeding this in multiple different ways, in multiple different scenarios. So by default, when you say who are you, it will understand that okay, I am trained to say DeepSeek. It's like similar to a child. It will just say like whatever it's trained to. Okay, there is no embedding or and I don't know if I can say embedding here because embedding also has a meaning in machine learning. So I'm gonna say there's no wired up uh, DeepSeek this name here by the DeepSeek people. Okay, it's how it has been trained to say. It has been trained to say it's by DeepSeek. Okay, so you saw the entire narrative, right? So before it remembered it's Cairo, but now once I removed it, it doesn't remember it's Cairo. Okay, so this is what we're gonna deal with today. So my goal is to set up SQLite and to store the conversations. So every session, maybe we can take every session we create can have an ID, and then we store all the conversation below that ID, it's like grouping with that ID, and then whenever we, whenever what do you say, whenever people wanna resume that particular chat or if they use that chat ID, we're gonna fetch all those chats. We're gonna send it as a response. So how do we do that? Very simple. So whatever you see here, role system, role user. So you'll have one more additional role here called assistant. So you're gonna just populate this. So we'll store it in a serial way, like assistant user in a proper ordered way. So what we're going to do is we are going to just copy paste that here from our DB, do the payload, and then we're just going to send it. That's all we're going to do. Okay. Nothing complex at the moment. Revert this. All right. So the first thing we're going to do is we're going to set up SQLite. And I'm going to Google it. SQLite setup. Or I can just ask Cursor to do it also. Uh, just go to plan. No need to plan. I just gonna. It's a simple SQLite setup. Set up SQL DB here. Let DB do not initialize with any tables. I need the database. Use bun. Okay. I mean, still there are some Cloud MD and cursor rules. It says you explicitly that use bun, but I'm gonna just still add it. Okay. All right. Let's run this. It should take care of everything. So these are the small things which doesn't create much value to me. Like if I'm doing SQLite by myself. So I'm going to use agent for that. Okay, cursor or plot or whatever it is. So if there is something that's challenging which gonna improve my cognitive ability, then I'm gonna code that by myself. That's how I'm gonna balance both. Okay. So now seems like we have it. So it used Bun SQLite. Oh, Bun has a built-in. Oh, nice. And then no extra packages and a small db.ts file. What does this file say? So harness SQLite data. Okay. So we created a data.sqlite here and a db.ts file as well. And it also initialized db. Perfect, perfect. And now, what does it say? Verify the file created. You can then create it. Perfect. Now here's what I'm going to do. I'm going to tell it, I need you to create a migration. Migration for a new table. I'm gonna just this table would contain conversation. So we'll name it as conversations, and you will store these data as a JSON. Use any row create data type for this. I don't remember what's exactly the JSON data type in SQLite, because in Postgres, I think we have bjson or something. I don't know if it's on Postgres or MongoDB. I think it's in Postgres and MongoDB also. MongoDB also stores it as bjson. And in MySQL, I think it's varchar something, like you're gonna say like unlimited text or something like that. But I don't know what is the appropriate data type for the SQLite. You might think that I'm dumb here, but I'm not. Okay. And then what we're gonna do is we'll say like just store it as JSON using appropriate type, and we'll use an ID as primary key, and this ID would be UUID 4. Actually, UUID v4 is fine, but I've read somewhere UUID v7 is even better. I've ordered, yes, this one, UUID 7. This would use UUID. V7 is preferred. If not supported, then I'd be open for V4. So remember, also observe the way I'm also prompting it. It's not like my prompt is perfect, but I'm still learning. But still, I'm explicitly suggesting what I want. Okay, writing it properly and giving it options also. So these are very small targeted requirements, right? So cursor doesn't have to like hallucinate anything. And in the future, moving on in the upcoming parts, I'm going to also show you how I plan an actual feature, like a complete end-to-end feature, and how I would iterate in a planning mode until the plan is end-to-end ready. So there's no room for assumption. There's no room for hallucinations there. I'm going to show you that also. Okay. So now we'll check SSID. It says no migration system exists yet. I'll add a runner and the first migration for conversation, UUID 790 and JSON stored as text. So it did some things. It added migration script. Let's check that migration script. Key data. This conversation data. Okay. And okay, migrate the TS file. So db run create table if not exist. Okay. Applied files file. Okay, it wrote like a custom made migration for TS file. So what it's doing is it's going to read all the files from this directory. So how many, like if you have like multiple files, it's going to loop over those files, and then it's going to just start applying these SQL statements. And also notice one more thing here. It's going to do it as a transaction. Okay, so that if something fails, it's going to roll back. And there's also one more problem here. It's using db exec, which is deprecated. So it says prefer db run. So let's just change that to run. Oops. Okay, perfect. And these things are ready. Let's apply the migration. So I'm gonna just run bun migrate, because bun migrate script is added in the package JSON file up here. So let's skip what? Oh, I think it's already created that. View this here. Perfect. Is there any extension? SQLite.
SQLite Weaver. Yes, I trust it. I have no idea who it is, but I trust it. Don't do this. I'm only installing it because it has like 600,000 installs. Topic with install. So if I open it. Yeah, conversations. It's done. So we have uh, this one. We have a row apparently. Cool. No worries. Let's just ignore it. Coming back now, since you have the data ready, right? We have the data ready. So not data, database ready. Now, what we need to do is let's run this script again, index.ts file. But this time, I'm going to just console log the choice directly. Then I'm going to do JSON stringify for this so that it's going to log everything. Okay, it's not going to collapse it. So here, I'm going to clear this and then run this. So once I do, here we go. Message for role assistant, as I told you. Content question like a key termination blocks, blah, blah, blah. And then you can also see one more thing, right? It says reasoning content. It says we need to respond as Cairo, a helpful assistant. The instruction says you will always respond with metaphor in the beginning, followed by the actual response. So first a metaphor, then the actual response. The user asks, hey, who are you? So the metaphor should relate to identity and instruction. Then the actual response, introduce myself as Cairo, helpful assistant. This is the reasoning content. What is reasoning content is, this is what the model thought, okay, before coming up with this response. So this is the capability of reasoning models, okay. There are reasoning models and there are different LLM models. So what we're using is a reasoning model. So in reasoning model, it thinks before it responds, okay. Thinks in a sense, it's going to take a step back. It's going to analyze what the requirement is, and it's going to come up with certain steps on how it should respond to it, and then it's going to take a proper steps. Okay, and we have the response here. So what we're going to do is, all I need at the moment is role and content. I don't want reasoning content because at the moment it's not relevant for us. So in the next iteration, if you send this again, it should be fine. And to reduce this unnecessary noise, what I'm going to do is I'm going to remove that. It says your helpful assistant, your name is Cairo. I will remove this metaphor thing so that it's not going to populate or pollute the response with unnecessary text. Okay, so now if I clear this and if I send a request again, I should see a very simple response. There we go. Hey there, I'm Cairo, helpful assistant. I'm here to answer your questions, insights, help, or whatever. In the reasoning, it says, the user is asking for my identity. Simple introductory question. I should give a friendly, clear response. My name is Cairo. I'm my assistant. I state my purpose briefly, helping with, like, you get the point. It's just thinking in a different way now because we removed that metaphor. And all this different way of thought was affected by the system prompt. So, system prompt, you should now understand the system prompt is your base, a foundation. So it's like giving an identity, purpose, and also like specifying how the agent should behave, how the agent should think. Okay, the way the how well you optimize your system prompt will define how well your output or the thinking capability of a model would be. Perfect. Okay, so we'll clear this. All right, and then I'm gonna accept something called history. Okay, I'm gonna accept history, which will be like any null, whatever. And I'm getting already bombarded with the cursor suggestion. So I'm going to accept it. So what we're doing now is we are taking this, okay, taking this role system. So we're having the system prompt here. We get all the history from before. It can be like all the previous conversation by the user. And then we're going to do role user, what the current prompt. Okay. And then I'm going to send this message. Okay. I'm going to send this message to the payload. That's all we're going to do. Okay, we're going to attach it to the payload. We're going to send it. Okay, and this would be optional. Okay, if this would be optional. And since it's optional, okay, what I am gonna do is I am gonna say we might have to like improve this a bit. So hmm, if history if history exists, then you are going to pass the history. Okay, or else you're gonna pass. Oops, sorry, not this. We're not gonna do mapping here. This is bad. We have the system message now. So now we're gonna check if history exists. If history exists, I am going to send all the history. Okay. If it doesn't exist, I am going to send. Oops. Oh, it was almost correct. Role user content. Okay. So what we're going to do here is, so we're checking for history. Okay. If history exists, we are going to send all the history messages. If not, we are, oh, wait. Then there's also one more problem here. If history exists, we are also going to send. Okay. So if history exists, we are also going to send the user prompt also. Alright. Okay. And now what I'm gonna do is I'm gonna add a, what is this problem? There we go. Okay. TypeScript issues, man. Okay. So what we're trying to do is we're checking for history, and if history exists, we're gonna include the history and also the user's current prompt also. If the history doesn't exist, we're only gonna include the user prompt. Okay, nothing else. And then we're gonna just send it. So let's test this first. So we at the moment we're not sending the history. We are only sending the system prompt and the user prompt. So hey, I'm Cairo. It's correct. Perfect. Now let's go back. Okay. So here, what I'm going to do is here, get history. History. So in the main function, I'm going to accept the chat ID, and this would be optional. So I'm going to make it a string. Okay. So now what I'm going to do is, hold on, cursor, hold on. Const history equals await db dot. I think it should be run. Yeah. Select from chat ID. It's if it exists. Correct. If chat ID exists, we're gonna do this. I'm gonna store let history on top because I don't wanna. Oh, is this a synchronous operation? It's not async. Okay. So what does it say? Changes following property pushback. Okay. I think so. We're gonna get result. I don't know the return type also. Might have to check. So it should be result dot changes. Okay. db dot query. Expected one argument but got two. As I told you, this is my first time using what is this thing? What is this called? Um, SQLite. So I might have to struggle a bit. So I hope you guys good. Skip. Come on. Hmm. Let's see what does it has to say. Oh, so oh my God, it's just doing everything, man. All I asked it to was validate things, but it's just writing all my code. Fine, whatever. Right. Accept this. Keep. So what it did was it's selecting it, yeah, query, exactly. Query. It used query, and then we have to do dot get. Dot get ID would be chat ID. Okay, and then as data. Okay, and then we are adding the type. Okay, got it. So we check if the rows is available. If the rows is available, we're gonna parse it, and then we are going to get the messages. That's the actual. But I don't think it's messages. It should be data. Okay, data is here, and messages here. So messages are the internal ones, and then we're gonna get it. Perfect. Okay, and then we're gonna share the history. So now, let's see how this works. So I don't have any chat ID at the moment. There's also one more case we need to handle. What if the chat ID doesn't exist? So that we have to handle. We'll handle that later. So next up, what we're gonna do is we're gonna store the actual messages. Okay, so the response we get is message. Okay, so I have to do choice dot message. So here's what I'm gonna do. I am going to say history dot push. Yes, history dot push. Right. Role chat message dot role. Okay, and chat message content. So instead of doing all this, I am going to remove this. Okay, and then all I'm gonna do is you can spread the chat message here, but if you do that, you'll also be including the reasoning content as well. So I don't want to do that. So what I'm going to do is I am going to destructure it. So I'm going to say like role and content, and then yeah, I'm going to just add it here. Role and content. You can do both ways also. This is a bit cleaner to read. That's all. Okay, and then I can remove this from here. Okay, we're going to go store it there. And the problem is now storing it to DB. Okay, storing it to DB. I think so. We might have to create our own key. So that the problem comes here would be this is fine. I can run this chat ID. Okay, if it doesn't exist, if the chat ID doesn't exist, we are going to do UUID. Do we have any UUID function from bun? Bun UUID v7. Then rate of the UUID. Bun should have it. DV4 works with bun. In bun, you can also do bun dot. Okay. So if it doesn't exist, we are going to do this. This is going to give you, I think, text data. You might have to convert that to string. Yes, there we go. Why is this a problem again? Object literal gnome property ID does not exist in type. Very binding. Hey, okay. Oh, the syntax was wrong. Thanks. It was doing query, not insert. Okay, right. So we have bun random UUID 7. And then what it's doing is, if in case we have the chat ID, we're going to update the same thing. If oh wait, if the chat ID exists, we're gonna have to uh, insert. Yeah, I think insert works. If we just insert it the same ID. Oh no, I think we have to update it, right? If the chat ID is specified, we need to update insert. Oh my god, it's 30 minutes, guys. No idea how the time is flying. Alright, I just started developing it. Yeah, exactly. See, update. Update set data, and then we're going to set the data, and then again it's okay. It fixed it. Cool. I'm going to keep the file. Okay, so this is what we're doing. So I think so we're fetching all the data properly, and then we're doing it. And now, uh, let's go. And it's also added the process arg as well. I think so we need to send the ID. Something like this. So at the moment, I don't have any ID. So I'm gonna just say bun index. I'm gonna tell it my name actually. Hey, hi, I'm Pavan. Who are you? Uh, So I'm gonna clear this. I'm gonna do bun rank index. Oh, I didn't add console log. Okay, no problem. Let me open up the database file. Oh, we don't have them. Oh, we have the message. Okay. It says, hi, hey Pavan, nice to meet you. I'm Cairo, your friend here, classes. Now I'm gonna send it another message. Before doing that, I'm gonna copy this ID. Okay, I'm gonna copy the ID. I'm gonna go to index.cs. Hey, what is my name? Okay, I'm gonna ask what is my name. Alright. Again, it doesn't remember if I don't pass the previous conversation to it. So now I'm gonna run one index with the copied ID. I'm gonna send it. So now I'm gonna go back to the database, refresh it, check it out once. It says you told me earlier that your name is Pawan with an emoji. Nice. So it remembers now. What if I remove the chat ID now? So if I remove the chat ID, we're not sending that chat anymore. We're creating a new chat. If I send it now, let's see what it says. I should have console logged. This is tedious. We have another chat. I open this. It says I don't actually know your name since you haven't told me yet, but feel free to tell me if you want me to use it. See the difference now. So when we send the message or when we send the previous context to it, it remembers it. Okay, agent has no way to store data. So all those RAG, all those vector storage we do, it's all on us. We do it outside the agent. So right now what it's doing is it's just predicting based on whatever the data we send it. It's all stateless. Okay, we call this entire paradigm as stateless. So if you see here, um, this is the LLM, okay, and it doesn't have any sort of DB. Okay, it doesn't have any sort of DB like that to store whatever data I'm sending. It's completely stateless. Stateless in a sense, whatever the request you send, okay, whatever the request you send should have all the data that defines that request. Okay, it can be like your authentication token. Why am I sending this? So for example, forget about the agent thing. What the hell? Oh, okay. If I come here, this one, check this. Why am I sending authorization header with every request for DeepSeek? The reason why I'm sending is because DeepSeek is not storing this auth token in their DB or anywhere else. It's completely stateless. So every time I request them, I have to say, hey, I am Pavan. Hey, I am Pavan. Here's my authentication token. They will validate it, and once it's validated, they'll be like, yeah, you Pavan. Go ahead, do your request. And next time when I show up, I have to again tell them that, hey, I am Pavan. Okay, because that's stateless. If it was stateful, they would have stored my identity somewhere. And whenever I show up next time, I don't have to say I'm Pawan. They'll be like, oh, you're Pawan. Go. That's how the entire thing works. So, all right, coming back here, it's pretty good now, right? So we were able to get one thing up. So now our context is being passed when we use the ID. And the agent can remember what we were able to talk. Okay. In the next part, we're going to talk about compaction. So now we are sending context. This is very simple. So we have one message, the agent's message, the system prompt here, and another message. Very four message, very small, right? What if we have so many lengthy messages now? Okay, how do we handle this case? Okay, so we need to handle this efficiently, right? So we're gonna, in the next video, I'm gonna work on context compaction, figuring out how to do that with you guys. Okay. Till then, thank you so much, guys. And I remember that in the last video, you guys said the voice was a bit fast. I did it deliberately to reduce the video content. So I'm not gonna do that now. Okay. Right. Thank you.